I'm here today to present top tips for using traditional Synergy in Visual Studio, but I've just shortened that title to Top Tips in Visual Studio because I'm pretty sure we're going to talk about some .NET stuff too. So let's just go ahead and dive right in. So on the SDI team at Synergex, it's our goal to help all of you be the best developers that you can possibly be and help you get the most out of your development tooling investment. Visual Studio delivers a massive amount of features and functionality that can be downright overwhelming to a newcomer. It is easy, even for an experienced developer, to gloss over a feature that could actually make your day-to-day development experience even better or more efficient. My presentation right now is designed to drill into a handful of features that we think all of you should be using in order to be more productive, efficient, and confident when working inside of Visual Studio. Some of this will be a rehash for each of you, but my hope is every single person in this audience will pick up something new that they haven't seen before or have seen and didn't already know how to do, so that you can get the most out of VS. We'll jump around a bit in terms of complexity. Broadly, we're going to cover features and tips from the editor, think inside the source window and the surrounding toolbars, the debugger with its specific toolbars and windows, and projects, how configurations work. I don't think that you'll necessarily use the project stuff every day unless you're a member of our professional services group, but getting it right will save you a lot of time and headaches in the future. And before we dive into any of these categories, I want to stress that the best way to get the most out of Visual Studio and SDI is to stay up to date. Microsoft is releasing Visual Studio updates and patches at a faster pace than ever before, and we are right there with them, making new compatible versions of SDI available. Our developer builds bring feature updates, bug fixes, and compatibility fixes on a much faster cadence than the regular Synergy patches. So it's pretty likely that we'll have a developer build out for SDI after the conference, but the next Synergy patch won't be out for quite some time. So I'm going to give you the single most important tip for Visual Studio right out of the gate. The top tip is to give your developers enough hardware. Fundamentally, Visual Studio is a very demanding tool. You need to give it enough resources to get the job done, and then you're layering our compilers and features and functionality on top of it. So spending a little upfront on hardware will save you and your developers so much time. At bare minimum, you need to get your developers a system with 8 gigs of RAM. 4 gigs is barely enough to run the OS in Visual Studio. Go bigger, go better if you can. For any serious development, you'll need an Intel Core i5 or i7 equivalent with at least 4 cores. A dual-core processor will run it, but it doesn't give you enough threads for all the parallel operations that are going on inside of Visual Studio. And finally, make sure that your dev machines have SSDs. No source code on network shares. Do all of your development locally on the SSD. It makes a huge difference. If you've never seen it, try it. Your compiles go so much faster. The first section that we're going to talk about is the editor. The first thing that I want to talk about in the editor is finding things in code. By now, I hope that you're pretty familiar with some sort of finding functionality in Visual Studio. VS gives you a few techniques for finding what you're looking for in code. So the inline find and replace is pretty straightforward. No fuss. It's no fuss. You can find and locate a text match. It's really easy. You just Control F and start searching. By default, it's case insensitive and scoped to just your file, but you can change all those options if you like. It's also powerful enough to do like regex, expression, search and replace, scopes down to the current selection and all the way up to all the files in your solution. And if you like, you can route this result to a different dialog, but by default, it's going to be a next previous sort of deal. Well, much like the inline version, the Find in Files dialog lets you search for text with or without case matching, scope, regex, but also lets you apply some more filters. You get control over how and where the results are displayed to one or more results windows. You get to choose if you want to append to previous result sets or not. It also lets you search directory structures outside your solution if that's what you want to do. Now, each of these find features are great at what they do, and I wouldn't be able to get through a single day in Visual Studio without them. But the real magic in Visual Studio comes from symbol-based finds, which we will get to in just a moment. So you get to symbol-based finds. This encompasses features like find all references, go-to definition, and solution explorer search. Symbol finds work off of compiler-driven understanding of your source code to locate and deliver the real thing in source. So when I ask my editor to go to definition on a routine call to Fred, we go resolve Fred to the real location as understood by the tooling rather than just finding everything in your solution called Fred. How many times have you had a variable or routine and file name all with the same word, like window or location or display in them? Text finds start to fall apart when channel or cust becomes the most common word in your source base. When you perform a find all references on a symbol, we go and locate every reference to that symbol in your source code and populate it into a toolbar. It may not be the most pretty interface for the data, but we are updating that in version 11. But it gives you a really accurate picture of how many times that symbol is used. You can double click on any item in that toolbar to navigate to that location in code. And I do have a sneak peek of what this looks like in version 11. It doesn't really match up with the color scheme that I have because I had to get someone back at the office to take the screen cap for me. But you can see that we break it down by project and then symbol, and we can show you a preview of where that symbol is used, as well as the line and column number, so that you aren't just blindly picking them and trying to figure out where you're going. Now this works great if I already know which symbol I'm looking for and can interact with it in source, but what if I really need to search for a symbol defined in my code instead? Maybe I only have a fragment of its name. Do I need to use text search? Well, no. So the Solution Explorer search is a broader type of symbol locating mechanism. Rather than focus on exactly one symbol, it takes your search string and tries to find a matching file names and symbols throughout your solution. If you only have a partial name, it's no problem. We are happy to supply everything that matches your partial name, and we do it very quickly as well. I'd actually like to give a shout out to Ace on this one for doing a lot of the perf testing around this. The CU code base is huge, and we've got this returning results very quickly, even for those common short strings. And then for go-to definition, at its core, it's a mechanism to let you quickly get from the usage of a symbol to the location where it's been declared. It sort of blurs the line between a find tool and code navigation tool, but when working in Synergy, go-to definition can do so much more. I can navigate to locals, routines, fields, type definitions, but I can also get to the declaration of my repository. But what if I wanted to see what's inside that repository structure? You can absolutely do it. Just hit F12 again, and we'll show you the guts of that structure. This is what we call a metadata view. We're showing you source content that is not a real source file, but looks and acts like one. So this can be way faster and more user-friendly than cracking open the old repository if all you really need is a quick and dirty look at what goes into that structure. This also works if you just go to def on a member of that structure, so it goes straight into the metadata view rather than roundabout have to go to the structure and then go inside. If you're a Synergy.NET or C# user, you are likely used to the metadata sort of behavior, taking you to generated view of .NET framework types. The neat thing is we also support go-to-def inside of those metadata views, so you can go to def while you go to def, while you go to def, while you go to def. But seriously, it's great if you're trying to follow a chain of like class inheritance deep into the .NET framework, so you can just see that type I extend, that type I extend, that type I extend, and just keep following it down. I think this is also probably a good place to show you one of the new features that just arrived in 10.3.3f. Clearly, I can go to definition on things that are declared in my own code. I get the neat metadata thing for my repository structures. But what happens if I go to definition on a Synergy keyword or built-in? It goes to our documentation. So as long as we know for certain what the thing under the cursor is and we have a way to be able to source where in the documentation it is, we will go to it. It opens whatever browser you have configured as your default and will just render it to you. You can trigger it with a go-to-def like an F12. You can also do F1, which is ask for help right in your source editor. It's still a really new feature. We do know of a couple limitations in it, like it doesn't do anything with like a begin keyword because we don't have a symbol backing that right now. but we are working on improving this for future versions. Please give it a try. Let us know what you think. I know the doc writers are also pretty excited to have you guys using all the doc pages even more. So the next area in the editor that I want to talk about is maximizing IntelliSense. IntelliSense is something that a number of us in the room probably take for granted as a must-have feature, but I expect there are some developers here that have only had limited exposure to what it can do. The first feature that I use, basically with what feels like every line of code I write, is completion or complete word IntelliSense. The basic concept is that we recognize words and word contexts within your code and attempt to offer words that are useful at that position. Am I on a source line where I need to access one of my local data fields that are defined in the scope, or maybe a field defined in my record or a class field? When I start typing those first few letters, I expect the editor to recognize, offer, and filter names that are relevant to what I'm typing. So up here, I'm typing my cust, and I only got 2 letters in before it knew what I wanted and made it available. Completion also has some cool behaviors with like the new keyword when working with object-oriented code. Usually your new expression is on the right side of an assignment, so you're putting that new object into a variable of some kind. And the completion system can usually figure out the type of that thing on the left-hand side of the expression and offer you the right type that you're trying to new. So in this example, I have something that's declared as a list of string. It's a generic. How could I possibly know? Well, we can figure out what my list is and know that it's a list of string and offer that to you in the completion. Pretty cool, right? And the next piece that feeds right off of the completion is list members. This is super prevalent when working with object-oriented code or any type of data structure with multiple fields. Say I'm working in a subroutine and I'm given a repository record as an argument. The last thing I want to do is have to always remember every field on that structure or have to go to the reference of the repository, go reference the repository and schema every time. So in code, I just type the name of the argument and type a period. This will trigger list members IntelliSense, like you can see up on the board, and it will tell me what members the thing has. You can also mouse over those things or up and down arrow key through them, and it will tell you the types of those things, and it gives you a lot more clarity when you're working with any sort of data structure. And what if that member that I selected is actually a method from a class instead of a field from a structure? Now I'm going to call a method, and I really want to know what its arguments are. Do I need to go to definition to that method just to see what arguments are available? No, definitely not. What if it has overloads and I have to go look at each of them? Of course not. When you type your open parentheses after typing that subroutine or function or method name, and we're able to resolve it because of strong prototyping, the routine signature help or parameter info IntelliSense will offer you an inline argument list with their names and types, as well as any relevant doc comments that may have been available on that routine. So it's all neatly inline, and it's pretty great. And we can't mention IntelliSense without mentioning a few of the other features that it offers or are built around it. All of the completion and list members and parameter info are nice, but what about when I'm looking at existing code? All of those features are focused on writing new stuff. Well, there's an answer for that, and it's called Quick Info or Hover Over IntelliSense. Quick Info will show you the relevant information about any symbol that you hover over with your mouse cursor. If you look at a variable, it'll tell you about what kind of variable it is and who declared it. If you hover over a method or subroutine call, we'll show you the definition, arguments, and return type if it has one. As with everything in Visual Studio, there's a hotkey for this behavior as well. So if you prefer never to take your hands off your keyboard, you can still do that. And the next one I'd like to talk about is quick actions, or light bulb, or smart tag, or whatever name it has at this point in time. When this feature is available, it's presented as a light bulb icon on the left margin. And it means that we, or Visual Studio, think that there is something clever we can do with your current line or block of code. Quick actions are automatic, context-sensitive actions that modify your source in a quick and useful way. Right now, we only offer a couple of them, but when you get used to them, you never want to be without them. The easiest way to get a quick action icon to show up is try to use a type that you have not yet imported in your source file. Say, for instance, that I wanted to use PSG's PDF API library off CodeExchange or GitHub or wherever it lives. I download the source, get the project all added and referenced in Visual Studio. Finally, I go to my source file and try to declare a variable as PDF file. It's not there. It doesn't work yet. Of course, I haven't imported the namespace yet, but there's a handy little light bulb icon in my margin, and I can click on it or control period and select the offered action of import namespace syn.psg PDF. And as you saw in the demo, it will automatically add that import to the top of the file. And I can just continue working. It's really great, especially when moving code around to like new source files or hacking away at a sample or just about any time that you're working in object-oriented code. The other quick action that we currently support that you saw in the demo is not super relevant to traditional Synergy, but we have to talk about it anyway because it's super awesome. Say you're writing a new class and you want to implement a few interfaces on the type. You'll add your implements iDisposable or some really cool interface. And you're all set to go about the mundane task of stubbing out all of those required properties and methods that are required for that interface. No, you're not going to do that. You're going to click on the really cool light bulb that's offering to implement it for you, either explicitly or implicitly. And it's not going to, write all of your code for you, but it's going to generate all of the method and property stubs so that you don't have to, and you can start filling in your implementation. And finally, in this section, the IntelliSense section, are snippets. I'm going to assume that most of you have seen a code snippet before in VS. We ship a number out of the box to make it really easy to add all the boilerplate begin-end statements for your various constructs. So if you need a namespace, you just start typing name. You get namespace in your completion list, and you hit enter or tab to finish the completion. Then you just hit tab again to expand the code snippet. And I'll show you a sample of how quickly it is to use snippets to just, boilerplate out a piece of code. Constructor is my favorite because it automatically gets the name of the method right based on the context of the class you're in. And there in 6 words and a handful more key presses, I have this big chunk of code that didn't exist before. So the other thing about snippets is that you can always make your own. I'm not going to go into the details of how, but you can add your own, and Microsoft has some really good documentations on how to do that in Visual Studio. They're really popular for PSG and presentations because you can just get snippets to do all of your coding for you, but Other editor features that I want to talk about before we move on. The first one is one that I've demoed a couple of times, probably years ago, and we showed you how to do it in both Workbench and Visual Studio. I still maintain that it's way too cool of a feature to be ignored, so when you click and drag your mouse or hold shift and use arrow keys, you get to make a selection in code, right? And once you have a selection, you can copy and paste and replace or do whatever you need. Select code, do something with it, cool. But if you hold Alt while you do one of these things, the dragging or the key press, the selection is not dragged between the cursor locations, and instead it creates a block comment, a multi-caret selection that's called a block edit. So when I have a block edit active, anything that I do after the point by typing or backspacing or whatever it is, it's replicated across all of those positions. I think that Synergy is pretty great for this feature because I can block edit an entire data section worth of data types at once and make the modification. So in this simple demo, I obviously just want to change all my A20s to A40s. Maybe not super realistic all the time, but knowing that it's there is great. And finally, this other one is an ideas feature that made it into 10.3.3f. It's called goToBrace. I know our language doesn't have braces in the same way as C or Java, but we do have keywords that very much fulfill the same purpose as braces. So now we offer brace navigation or goToBrace as one on as many of our keyword pairs or triplets as we could find good use for. This means you can quickly and easily swap between begin-end statements or class-end class or subroutine proc end subroutine. And I think it's seriously cool, especially the way that it'll go through the 3 different items. And thank you, Richard, for submitting this idea through me onto the ideas site. I'm glad that we have it. The next section is the debugger. Editor features are great, but we have a tool that lets you step through your running application, view state, evaluate variables, and get a clear picture of how your application is running. Debugging is a must to master if you want to quickly evaluate and fix bugs, or get an idea of the flow of unfamiliar code. I am going to start really basic because I happen to know that there are people in here that are not used to working in IDEs or are hesitant to make the switch. If you have not used a visual debugger or any debugger, I think that this is the killer feature to get you into a Visual Studio environment. So stepping is the most basic operation that you can do in a debugger. A single step moves you forward through a program's logic, letting you see the state of things at each step of the way. You can choose to step into an item where the debugger will try to follow the execution point into a routine call, or step out, which will let you proceed up the call stack back into the caller of your context. And finally, you can step over, which will let you advance the program logic within the current context, but not move into routine calls. There's basic activities that you can do while in a debugging session that will let you advance program flow. But the magic of the feature comes from being able to evaluate the state while stepping. If you hover over one of your variables, you'll automatically query the value of that variable at the current point of execution, and you can observe what is in it. There's a toolbar that has the step over buttons, but I think the hotkeys are the way to go. And they fortunately have them in the tooltip. So when you hover over, you can observe what's in a variable. You can then pin it. There's a little pin icon into your program, and then as you step, that will automatically update. But how you view values of your variables or records or fields is up to your preferred workflow. We support a tool window called Watch, which lets you input the names of several variables and fields into a watch list, so you can watch their values change over the course of your program execution. And when the value changes, it's displayed in a red color to draw your attention to it. And then if it goes out of scope, it'll gray out or say could not evaluate, something along those lines. If you'd prefer to look at the values of every variable in the field in your scope, there's an option for that too. The locals window will show you the whole world according to the current stack frame of execution. There's some considerations when using this tool though. All of these evaluations in the debugger aren't free operations. Each one has some execution time and overhead, and a locals window with the scope of hundreds or thousands of variables will make it a little bit noticeable. If you're not actively using the locals window, I recommend having it hidden, like tab it in the same way you do with your watch window or something else. That way the debugger's not constantly evaluating every single variable in your scope. I also need to mention that object property support is pretty limited in traditional debugging. So if you've got object-oriented programs and you've got a lot of properties, evaluation for them doesn't work great. We are making improvements, but it's still a very much for the future type endeavor. But for now, property evaluation is limited to simple properties, so without the get set methods. If it's got a get method, chances are pretty good we can't evaluate it right now. But hopefully we will make that better in the future. So breakpoints are the next basic piece that I need to cover that gives you a good basic toolkit for debugging. Breakpoints aren't spots for breaking your code or anything like that. They're an indicator for where in source you would like the debugger to stop so you can evaluate what's going on at that place. Rather than stepping line by line all the way through my program, I can just click in the margin to set a breakpoint at any arbitrary routine and the line that I want to view when the program gets to that spot. And the debugger will automatically freeze execution so that I can take a look around and poke at the variables and do whatever I need. We also have limited support for something called a conditional breakpoint in traditional Synergy. This lets you further refine your program execution flow by only breaking when certain conditions are met. If you right-click on a breakpoint, there is a conditions option. And we're basically limited to equivalency operations, so is this equal or not equal, that kind of thing. But if I really want to see what's going on inside my routine, but only when one of the local variables has a value of 4 or Fred or something like that, I can just break only when I want to, rather than having to hit that routine every single time until I get the right condition. I think that this makes you super, super productive. Other things in debugging basics, we have the call stack. And if I didn't talk about the call stack tool window, I'd be doing you a disservice. If you open up the call stack tool window, you can see the labels for all of the stack frames that lead up to your current point of execution. So while you can easily view locals and variables at a breakpoint, this lets you go walk up the stack if you want and see the locals and variables at that point of execution as well. So you, once you have it up, you just double click on an entry in that call stack tool window and it will take you to that location in code, and the debugger will be ready to serve you the appropriate data. When you're done, you can just double click back to wherever it is, your primary execution point, or just continue debugging or continue stepping. And then the last basic debugging feature is a .NET only feature, but it's too good to pass up here. When debugging in .NET, whether it's in Synergy.NET or C# or VB, you can alter program execution flow just by dragging the execution pointer. So this little guy, you just drag him up in the code, it'll let you just change the flow of operation. So in this simple program, I'm just incrementing a counter to demonstrate that it's actually moving the program execution and continues incrementing. So when you wind back to a different program execution point, it's not undoing all of the operations you've done. It's simply saying, I'm going to continue executing from here. You can also move forward in code. So if you're debugging something and you know this next thing is going to cause an error, you can just drag the pointer past it and keep working through whatever case you're in. But Marty, you're thinking, I do all kinds of Synergy things that seem like they couldn't possibly work correctly in this context. Do I still get supported? Of course you do. As long as the runtime and debugger can tell us the right information about your program, all sorts of paradigms will work great. Do you use stop chains profusely? That's not a problem. It's supported. Do you use Xsubber for everything? Yeah, that works too. Or RCB API, that works as well. Do you have massive monolithic routines that are tens of thousands or hundreds of thousands of lines long? That's not an issue. And do you have lots of reentrant local routines? That's supported too, but those routines don't necessarily show up in the call stack. So you have to have a properly fully declared routine for it to end up in the call stack. And for those of you that do it, you can also interop with the .NET API. You can attach a .NET debugger on top of the traditional debugger at the same time and debug both sides of a single running program. I'm not going to show you a demo for that, but the scenario, if it's something that's applicable to you, come and find me or Jeff and we can show you how to do it. And we also support even more traditional debugger functionality than what we give you in the GUI. The immediate tool window is somewhat of a direct interface to the traditional debugger that's running behind the scenes of our visual debugger. It's sort of a CLI to the debugger, which is a GUI on top of a transport layer on top of a CLI debugger. Anyway, it sounds really enterprisey and it works great. We let you use only the commands that are listed here on the page, but we think they're the most impactful commands that you'd like to have access to. I'm not going to cover what each of them does, but I would like to call out set watch and deposit specifically. The set watch command is a little different than the watches that we offer in the GUI because it behaves more like a C++ data breakpoint. When you set watch on a variable, we will break when the value of that variable has changed specifically. And meanwhile, the deposit command lets you set the value of a variable during your debugging session, which effectively lets you change the state of your program on the fly. So if you really want to test that weird edge case, you can just manipulate some data and get to it. I know that some of you are rolling your eyes still, thinking, none of this stuff applies to me because I run all my programs on VMS or Unix. Maybe you don't have any intention to get your code building on Windows either, but I am happy to tell you that you can still use this stuff as long as you've got a Windows dev box with Visual Studio. All of these debugger features will work in remote debugging. So as long as you start your program with the right arguments, you can debug your remote Windows, Unix, VMS machine comfortably from your own dev box. Once in a remote debugging session, all of your features, watch, breakpoints, locals, hover, stepping, everything just works correctly. But the process is running remotely on another machine. This also works to a process running on your local host if you want. So you could debug a previously built version of your program or someone else's program, as long as it's built debug and if you have some source available. So you can see starting the application, you have to have the right arguments, you give it a port number, you tell it the name of the DBR, and you click enter. Now the DBR is waiting in the background. It's waiting for that connection before it continues execution of the program. And we go into Visual Studio, we do attach to process, we tell it where, what machine, and what port, and we click attach. And it's running up over there, giving me a 14-day trial message, and now we're in the program. So I can continue stepping, I can step into, step around, click continue, get exceptions, review everything that's going on. So getting into it is really easy. We only have a few arguments that are built into DBR to make the whole thing work, and passing that -dv switch tells the debugger to run in VS compatibility mode. VMS is a little different, as you can see. You have to set the dbg RMT logical to the -rd and your port number and info, and then you just run the program as normal, as long as it's built debug. I do want to call out one feature. If you're doing a lot of attached to process, we do have this reattach to process that's added in Visual Studio 2017 version 15.8. So if you're doing a lot of reattaches, just make sure your program is running outside. If it's on the same port, just click debug, reattach to process will go to the last one that you were using. And remote debugging in .NET is just as easy as this. You just go into that attached processes dialog, and you can see all the .NET processes or the other processes running on your system. If you give it a remote machine name that has the remote debugging tools for Visual Studio installed, you can see the processes running there. We do offer a download specifically to integrate Synergy support into that stuff. So if you need a sample on that, I don't have one here. I can show you how to do it, but it's really straightforward. And one last debugging tip in error handling. It could look a little strange to you in the visual debugger when you get an exception. When an error occurs at runtime, we actually break where the error was caught rather than where the error was thrown. So when an error happens, the line of execution where it occurred has already finished. So you'll most likely see the error, like the debugger will stop on the next line of execution because that's where we caught it. If you're ever uncertain about the error, you can take a look at the information inside the exception. It will give you the relevant message, exception type, the call stack for your error so that you can have a full understanding of where this came from and what was running. And the last section is projects. Before we dig into the actual project configuration topic, I want to take a moment to discuss why it matters to get it right. For many of you, project configuration is a one and done deal or a once in a blue moon operation. In order to make that stay true, you must have complete and accurately configured projects. It's important because an accurately configured project will let you make use of rich IntelliSense features through strong prototyping, allows you to correctly select debug release, x86, x64, VMS, and Linux if you want, and be confident in the state of the build artifacts that you're generating. And more importantly, it will let you be confident enough in the output of your projects to use them in a command line build environment. Ultimately, that command line build confidence can help you more quickly reach a continuously integrated build process and make DevOps adoption that much easier. Not to mention your day-to-day developer experience will be way better. Sounds more interesting now, right? Maybe, maybe not. It's pretty dry, but we do have to cover it. So one of the first things that you should do when configuring a project is get your environment variables or logicals configured in a way that makes sense for your build environment. If you get these right, you will have a much easier time compiling your sources going forward. We recommend that you use the common properties page. This will let you define the variables and they can be shared across all of your projects. The environment variables page is separate and it is only variables specific to this one project. So when you define a variable in that scope, it will overwrite the same name variable that is defined in common properties. So you have some fine-grained control if you need it, but generally common properties will work for everything that you're doing. One of the great benefits of defining the environment variables in your projects is you now have an environment configuration that can be made easily portable between developers. It's all checked into your projects, so you just check it out of source control and you've got the environment configured correctly. And it also defines the configuration when you're building at the command line with MS Build. So you don't have to do environment setup first at the command line. You just MS Build the project. It already knows how to do everything that it needs to do. It's important to note that these environment variables are compile time and not runtime. So changes that you make here aren't going to affect your runtime. You still want to make those in your Synergy INI or figure out another way to populate them. We do have some support for it depending on what you're trying to do. We specifically have stuff for .NET that makes it work with some of the weird distribution options. It can be a little tricky to work out the environment variable precedence order. If you consider that you've got your system variables and your Synergy INI and your common properties and your project environment variables, my recommendation is just use common props. Don't try to work all of it out for your development environment, just do common properties. But if you really want to get a handle on how all of it works, there's a great article by our doc writers with a short URL there, or just search for environment variables and Visual Studio development on our doc site. So I'm not going to walk through all the property pages, but I need to make sure everyone's aware of a few key principles. You have to check your platform and configuration when you're making changes in the property pages. You see those two options at the top? Those matter a lot. We pre-populate traditional Synergy projects with two configurations, release and debug, and two platforms, x86 and x64. You can add stuff like Linux and VMS into the mix, and you very quickly have 6 or 8 or more total configuration pairs. In property pages that offer these drop-down boxes, you're editing settings for just that combination. So you're not making changes to all of them all the time. If you click in the drop-down, we do have options for all configurations and all platforms so that you can make sure that you're making changes that apply to everything. And for things that are different between them, it will blank out the fields so that you know that it's not the value that it's writing. If you do put something in there when it's blanked out, it will overwrite all of them. These drop-downs are distinct from the platform and configuration drop-downs that you probably have in your toolbar at the top of Visual Studio. So where you've got that start button, there's a debug and a platform there as well. Those drop-downs are selecting your target for build and debug, not your target for your property pages. In order to make it clear, the active name configuration is shown on the target that matches the top level environment. So when you're in these property pages, the ones that say active are those ones that are selected for your current build or debug settings. I'd suggest that you do all your initial configuration using all configurations and all platforms just to get it over with. And then if you need platform or debug or release specific changes, go ahead and do that. The build page is definitely the next most important piece that you have to get right, and that's still what we have up here. It's one of those pages that's impacted by your configuration selection, and it's this page where you tell us some of the very important things about your application, like what platform am I targeting, what runtime version am I targeting, am I in debug, or where are my output files going? You might think that the build platform target sounds redundant. It's actually distinct from the name of your platform. So even though the platform at the top says x86, I can change this drop-down to be something else, because those configuration names at the top are just names. For all Visual Studio or WeCare, your platform could be called Fred, or 10.3F, or Synergy DBL integration rocks. It's the platform target in the drop-down that actually tells us and the compiler which platform that you're targeting. That lower drop-down box is what actually matters for compile time. In general, your platform is going to match the other platform drop-downs, and by default, we make them match. You'll notice that we also populate them with VMS, Linux 32, and Linux 64 as options, but we'll talk about those more in a minute. The runtime version is important to get right so that you can deploy your application to the lowest version of runtime that you need to support. We've talked about it a couple times so far at the conference, but this drop-down box controls, do I want to deploy back to 9.5.1 or 9.5.3? But this will also limit the amount of features that you have available to that version of the runtime. We strongly recommend that you stay up to date on your runtimes for security and features and performance, but this is your option if you must deploy back to a customer that won't budge. Marking debug on there, you're probably not going to get it wrong, but if it's not checked, your ELBs and DBRs are not being built debug. So if you're having a bad debug experience, come in here and double check that it's set. And finally, the output path is really important to get right. We default this to a logical of xeder so that you know how this gets used. We just do that inline so that you can put this to the right place that you want your outputs. We expect you're going to use some other logical, but we use xeder. You can keep using it if you want, or if you've got something else, you can replace it. But this, by default, is configured to output to a configuration and platform-specific directory for your current build. So it ends up in a debug x86 folder. I have a few notes on the compile page. For those of you that are not yet or are soon to come aboard Synergy in Visual Studio, the Q relaxed option is your key to early success. This handy proto and compile flag lets you get over some of the hurdles to enabling strong prototyping. We relax some of the compiler strictness about your code base so that you can get into VS more quickly, but we don't really want you to keep these on forever. We believe that once you're in VS, it's so much faster and easier to work on your source code that you should start disabling these Q relaxed options as soon as you can, so that you start working through some of the source changes. This will ultimately improve the quality of your source code and reduce unexpected runtime failures. That's the reason to make source changes. These are here to help your code quality. But I really want to take it a step further. Get all the way unrelaxed. Get strict. We offer a Q require proto flag if you really want to crank up the compiler strictness and help you enforce your own code quality. This will enforce that prototypes for subroutines and functions always need to be available, not just resolved at link time. So it will help you ensure that your projects are correctly referenced, and that this will make sure that your IntelliSense will work the best it possibly can, since we rely on the prototype information ourselves. If you have a bunch of circular references in your projects, you're going to have a bad time with this, so work on clearing those out first. And I also want to touch on an option that affects executable libraries that lets you decide how you want to build DBOs with your project. By default, we set that option right down at the bottom of the screen to disabled. It's called compile source modules into separate object files per source. This default causes our projects to compile all of the subroutines and functions into one DBO file before running it through the link process to the final ELB. This is an optimization for compiling sources so that we can get the most value out of our caching mechanisms inside of the compiler. However, when you keep this default, it disables a little bit of our incremental build capacity. When you make a single source file change, that whole DBO worth of source has to be rebuilt, which will take more time than just building the small pieces. So the trade-off is slightly improved compile performance and a clean build versus pretty substantial hit to developer productivity when you are making frequent changes. My recommendation is to turn this option on. Just give it a check in your projects for your developers' sake in all of your applicable projects. We have some ideas on how to get the best of both worlds going forward, and we're going to be working on those. But for now, give this a check in your ELB projects, and it will make your incremental builds a lot better. Configuration Manager. It's a dialog for people that really like configuration mapping. If that's not your thing, that's fine, and this dialog might drive you crazy. This is a single mapping point to define what all of the other configurations in your projects across the solution are going to do. Like I said earlier, configurations are an arbitrary name, so all the names you see in this dialog are up to you. But in order to stay readable and easily understood by others, you might just keep them as debug and release and things that are sane. This is the place you want to go if you want to add VMS and Linux configurations to your project. So the easiest way to get to the Configuration Manager is right-clicking on your solution, selecting Configuration Manager, and now you are in this beautiful interface. Add a new platform. We pre-populate this with VMS, Linux, and Linux. You can tell it where you want to copy the settings from. So if you're already set up for x86, we copy it from there. And now the VMS platform is in all of your projects. If you did it through the Configuration Manager, it got added to all of them at once. If you do them individually, then it's going to take you a lot longer. And now when you go into your property pages for your project, you can see that the platform is there, and it has already been default targeted to VMS. And so what this actually does is, as Roger said, it tells the compiler to treat your source as though you're building on VMS. All of the defines in the compiler will be set to the ifdefs that are appropriate to VMS code. So it gets the right defines, it goes through the right code paths, and can let you debug your platform-specific logic in a Windows environment if you really want. And in order to make that happen, because it's not just compile time, we do have a VMS compatibility library. It's open source, and it's kind of a stub library for all of those system routines that you're looking for in your VMS code. It's a great fit if you want to do VMS development in a Windows environment, and this will let you actually run and debug them, even if it's not doing all of the same operations. Some of the stuff in here is implemented. Give it a look on our Synergex GitHub page. We will take your pull requests or let us know if you have things you want us to add.
Do you have any plans to make the SDI update through the Visual Studio extensions and updates option instead of downloading through the Resource Center every time?
That's a really interesting question. It's something that we've kind of talked about, but it is a whole different distribution method that we would have to be testing and verifying. So I'm definitely open to the idea, because we are mostly all of our stuff in the V6, so we could distribute there, but yeah, maybe we can have a conversation about it.
It did get 7 votes, so.
Wow.
Yeah, popular idea. What is the roadmap for find symbol results to show context? And then there's a smiley face at the end.
So are you talking, is this specifically the find all references, the new UI? We are intending to ship this in 11. If we have it ready sooner for a developer build, we'd like to push out features early, but 11 for sure, which I think is slated for Q1. Yeah.
Is the ability to display number of references to a routine a la C# something that is being considered? And if so, would it be clickable similar to C#?
Okay, so this is the adornments that C# adds at like a method declaration. So it's actually I think it's only an enterprise feature of Visual Studio, but it is really cool. So when you look at the declaration of the method, it shows you a little inline. I actually have like 45 or 50 references to this method. It's something I'm interested in. I haven't looked at what the APIs look like for doing those sorts of adornments, but generally we're still getting a little caught up on some of the neat adornment additions that they've added in C#. I am open to it, but I don't currently have plans.
This is a comment. It would be worth mentioning that remote debugging also works for XF Server Plus remote debugging. You just have to connect within that timeout you set.
This is true. And if you look at remote debugging in our docs, a lot of what was in my slides is actually there as well, and it covers how to do the XF Server remote debugging as well. Awesome doc pages. Matt Linder is great. Thank you.